Alright, this is chapter 2.4, solving systems of linear inequalities. We'll start with the vocabulary. A system of linear inequalities is a set of two or more linear inequalities in the same variables. Okay, so for example, if you have y is less than x plus 2, that's one inequality, or you have y is greater than or equal to 2x minus 1. Those together, this make a set of linear inequalities. Inequalities. Okay? So that's just an example of a set. All right. The solution of a system of linear inequalities is an ordered pair that is a solution of each inequality. I really need to work on my handwriting. Inequality in the system. Now, one thing you'll notice is, so for example, if I've got, I'll do my example in a different color. If I've got x minus y is less than 4 and 2x minus y is greater than or equal to negative 9. Now, those are both linear. They got an x and a y. What on earth just happened? There we go. And one solution would be negative 2, 5 is a solution. Now, one thing about inequalities, there are probably going to be infinite number of solutions. There is a possibility of having no solution, but because these are ranges, it's not just one point because you're dealing with less than or greater than, but this is one solution of the inequality. Last but not least, a graph of the system of linear inequalities is the... change colors. The graph of all the solutions solutions of the system of linear inequalities. Alright, and so for example, let's go over here. I'll draw a quick graph. Let's actually draw a little bit like this. Need some space. So if we have y is less than x plus 2.
Daddy.
Okay, I just stuck them up here right quick. The orange line is the equation y is less than x plus 2. And the green line is y is greater than 2x minus 1. Now, a couple things to note about this real quick. First things first, why is the orange one dotted? Well, the orange one lacks the or equal to. Alright, so it's not equal to the line, but it goes all the way up to the line. The green one is solid because it has the little or equal to line underneath it. So we can count the line. Alright, the last thing that we're missing is a shaded region. Because we are less than y on the first one, this one's less than, we want below, because think of it sea level. If you're less than sea level, you're below the water. Alright, so we want below the orange line. Now, the green line is greater than, so if you're greater than sea level, you're above sea level, you're above the water. So we want above the green, so we're below the orange, and above the green. So anything in this region would count. Now, when you shade this, try and shade relatively lightly. I mean, there's no way that I can shade lightly. Well, I don't know. Maybe I can. Can I change the opacity? Oh, yes, I can. Let's do that. So let's do, I can change it like this. Try and shade lightly. I didn't know I could do this. Where you can kind of still see points and things along those lines. Okay, so that is the region that is for both lines. Now, there's another way you can think about doing this. If you want to, you can say, well, the orange one is below. So let me change that one. So you go ahead and shade very lightly below. Just shade everything below. And the green one is above. So what I'm going to do is I'm going to shade very lightly everything above the green one. And then where they overlap, go ahead and make darker. Okay? So that's another way of thinking about it. If you don't want to think about them both at the same time, you can shade one, then shade the other, and then go back wherever they overlap, make it nice and make it darker. Okay? So that's just another way of looking at it. Okay? Well, there's your vocab.